Right again. One tree makes a lot more than one paper. Trig. Trigonometry. Trigonometric. Nick, be quiet. That very first equation we had, that is an example of something called a conditional equation. It's true for set values of the variable. It could be 1, 2, 3, 4. Oh, first equation. First equation. We've seen these already. An equation that you can solve and get x equals blah, whatever, that's a conditional statement. It's a conditional equation. So something that we've seen, if we say like tangent equals 1, well, there are specific values that make this true. We would go, if we're looking at just the unit circle, so from 0 to 2 pi, well, we could easily say that we've got pi over 4 or 5 pi over 4. We plug those in, we get 1, it's done. The second equation we had was an identity. Well, an identity, it's true for everything. You guys okay? If you need to go take a walk, go take a walk. Go for a walk. It's true no matter what we plug in. That was the second one. It's always true. We could pick x is 1, x is 5, x is 27. Who cares? It's always true. We've seen statements like this so far. If we take tangent equals sine divided by cosine, that's the definition. That's how we define it. We go back to the unit circle, tangent, opposite over adjacent. Well, that was opposite, that's adjacent. This is always true. You cannot argue with it. If we pick theta is 1, theta is 1,000,000, theta is negative 17. Who cares? It's always going to be true there. It's an identity. And that's specifically what we're going to look at with our trigonometric identities. We're going to have 3 different general types of trig identities that we're going to look at today, and this is going to guide us for the next month. We've seen some of these already. So we're going to start with our first family called quotient identities. Quotient meaning division. We've got tangent. Well, tangent is sine over cosine. We've got cotangent, quotient meaning division, so we've got division in there. Cotangent. How do we define cotangent?
1 over tangent.
1 over tangent. So, in terms of sine and cosine, that is cosine divided by sine. So it's an identity. It's a quotient identity because we've got this division in here. So whenever we see this, it's exactly the same as this. Whenever we've got this, it's exactly the same as what we have here. We've also got reciprocal identities, the second of our 3. And we've seen these before, where we define secant of an angle is 1 over the cosine. We've got cosecant, it's 1 over the sine. We've got cotangent, as we said, was 1 over tangent. And then we can take the reciprocals of these, where we've got tangent is 1 over cotangent. We've got cosine is 1 over secant. And we've got sine is 1 over cosecant. Those are all what we call our reciprocal identities because it's defined as a reciprocal. Flip the fraction. Now the whole point here is going back. What we're going to be looking at is how we simplify expressions, just like with the polynomials that we started off with. back before, we had to get good working with polynomials. Sometimes we had a statement like this, and we had to factor it using those identities. Sometimes we had a statement in factored form, and we needed to multiply it out to solve. So we're going to be working with our algebra of how to manipulate just now with trig functions and trigonometric expressions instead. So we've got these base identities of how we work with things. And this is going to be a skill that comes up if we ever take a calculus class or just you need to be able to manipulate different symbols. Calculus, if you've got some messy expression, if you can reduce it down to something smaller, it makes life a lot easier. Or just math in general. You've got something that's messy, you can condense it down to something that's easier to work with. So let's take a look at something. We have the expression cosecant divided by cotangent. Can we take this cosecant divided by cotangent, reduce it down, simplify it to just one expression where there's no division, no multiplication, no addition, no subtraction? We want to take this and make it as simple as possible. Any initial thoughts? What I see, cosecant, that's the same thing as 1 over sine. Cotangent, well, that's the same thing as cosine over sine. Well, we've got a fraction divided by a fraction as multiplied by the reciprocal, outside over inside. The signs cancel out. That's going to give us 1 over cosine. And what's 1 over cosine? That's secant. So we've taken this expression where we've got a quotient in here, some different parts, and we can reduce it down to just one term. That's the overall goal of what we're looking at. How do we simplify these expressions from something that's a little bit more complicated down to something that's a little bit easier?
And that's a reciprocal quotient.
This was a reciprocal because because it's the reciprocal.
Is that, yeah.
1 over cosine is secant. Let's try another one. Now, this really gets to work our algebra. We need to be good, confident, and solid with our algebra. Cosine of x times cosecant of x times tangent of x. Oh boy. Now, as I did with that last one, sometimes it's a good idea to switch it in terms of sine and cosine. Sometimes it's not. Now, what I like about simplifying expressions, working with identities, is it requires you to be a little bit creative. You've got to figure some things out, try different routes. You can spend 30 minutes on one example when there's a simple solution that could take about 15 seconds. Now, cosine times cosecant times tangent. Let's simplify as much, condense it down to as little as possible. Can we do anything with cosine? Cosecant? Well, this is cosine. That's 1 over sine. Anything we can do with tangent? That is sine over cosine. Oh, look at that. Times sine, divide by sine. Cancels. Cosine over cosine. Cancels. That mess just simplified down to 1. That's it. You okay over there?
Yeah.
Clash of Clans, you lost?
Nah, I don't have plans.
You gave up on it.
Yeah.
I thought you were committed, so like you just couldn't quit. Think about how much time you wasted with that, and you just walked away from those 2 years of nothing.
I don't play that one. I don't get rabbit. I don't play that one.
Not 2 years? When'd you download it? Freshman year?
Nah, I played it for like a couple months during the freshman year season.
And you haven't touched it since freshman year? Okay. We got Flappy Bird instead. I don't care. I honestly don't care. Cosine times cotangent plus sine. Can we reduce this just down to one term? Here's what I see. Cosine, can't do much with that. Cotangent, well, we've got all this other stuff. We could switch that to 1 over tangent, but we still have cosine and sine there, which is just sine over cosine. This is just going to be cosine over sine. We can switch it. This is where we need to know our bases. Cotangent is cosine over sine. So we can switch that out. We've got cosine times cosine, over sine plus sine. Well, we can combine bits there. Cosine times cosine. We've got cosine squared. I'll explain my notation in a moment. Over sine plus sine. My notation, I've written this, the exponent is right above the cosine. So, going back, and we'll go connect back to this. Cosine squared, I've written the exponent right above the trig function, the trig statement. This means the whole thing is squared. We write it like this to try and avoid any ambiguity of putting the exponent at the end. So if we wrote it as cosine of x squared, what's being squared in this case? Is it the entire thing? Is it just the x? This makes it look like it's cosine of x squared. So this is the notation we'll be using. This is what you see. This is universal notation no matter where you go to school, no matter physics, engineering, whatever you do around the world. So we've got, this is turned into cosine squared over sine plus sine. If it was multiplication, we could, but we're adding. What do we need in order to add those two?
Sine squared x over sine x.
We can multiply by 1. We can multiply by 1, and that's going to get us common denominators. If we multiply by sine x over sine x, we're going to have common denominator. We've got cosine squared plus sine squared. Oh, look at that. That's nice. Over sine. Here's what I like. Look at that. We've got cosine squared plus sine squared. Do we know what that is? That's just 1.
Why?
That's just 1. It's 1 over sine, which is just cosecant.
Wait, what?
But it depends upon this. Cosine squared plus sine squared. Why is that 1? Let's take a moment and go backwards in time. Go to our unit circle. Unit circle. We've got some angle. Opens up. Hits that circle at some point.
So it's x times y, which is...
Not quite. Go talk outside. Go for a walk. We can create a right triangle. Guys, shh. Go take a walk and talk. Well, this is x. That's y. How long is the radius? That's 1. How did we define coordinates around a circle? Well, x and y, yeah, but more importantly, what we've been doing recently, that's cosine of the angle, that's sine of the angle. Here we've got a right triangle. That's x squared plus y squared equals 1, right? Well, x squared is cosine squared. Y squared is sine squared. Well, based upon the unit circle, we have this identity that's true no matter what because the Pythagorean theorem is true. So we've got this statement that anytime we've got cosine squared plus sine squared, it is just 1 and done. Now this gets us our third family of identities where we've got our quotients, we've got our reciprocals, we have what we're going to call Pythagorean identities based upon the Pythagorean theorem.
10% of diagonal.
It happens. Hope the Pythagorean theorem yields cosine squared plus sine squared equals 1. And we can take this and we can manipulate it a little bit. We have a new connection between sine and cosine. If we take this, if I divide the entire equation by, say, sine squared, cosine squared divided by sine squared, well, cosine over sine is cotangent. We've got cotangent squared. Sine squared divided by sine squared gets us 1. 1 divided by sine squared, 1 over sine is cosecant. That's going to yield cosecant squared. We've got a connection between two different values. If instead we take this and divide by cosine squared, the original cosine squared divided by cosine squared gets us 1. Sine over cosine gets us plus tangent squared. 1 over cosine gets us secant squared. We've got a way of connecting different functions here. So we've got 1, 2, 3, what we call our Pythagorean identities. They're based off of the Pythagorean theorem. That all came from a unit circle. This is the one to remember. The other two we can figure out as we go along. But this cosine squared plus sine squared equals 1 leads us back when we were looking at this. We had this cosine times cotangent plus sine. We worked it down. We've got cosine squared plus sine squared. We see that typically anytime we see the exponents, we want to think Pythagorean identities. That's just 1. We've got cosecant. That whole thing simplifies down to one piece. How we doing?
Wait, so
I'm confused. I
can
lost.
you go the Pythagorean one? So that's how you would solve one of those?
Well, this is how we derive the other two. So if we take the first one and we divide everything by sine squared, we end up with a second one. If we take the first one, we divide instead by cosine squared, we end up with a third one.
Oh, okay.
So it's a
That's why we divided by sine and cosine.
this led to this. This led to this.
Are you always going to do that?
That's just a derivation for something that's different.
Okay.
Same way we could say that tangent is something else. Just different ways of simplifying, combining. Let's do another one. Sine plus sine times cotangent squared. Let's simplify it down to just one expression. Well, we got sine, we got the sine, cotangent. Sometimes it's a good idea to multiply. Sometimes it's not. Sometimes it's a good idea to switch things in terms of sine and cosine. Sometimes it's not.
When do we know when or when not to?
You try it. See what happens. One of my favorite things about this is there is not necessarily one set way of figuring it out. You've got to be creative. You've got to try out different avenues. Sometimes you hit a wall and you get stuck. Sometimes you get through something. This is sine of x plus almost. If this is squared, if we switch this out, we've got sine plus sine times cosine squared over sine squared. Does that help us at all? Well, yeah, that's the same thing.
Can you add 2 sine of x's? You can have 2 sine x.
Can I do 1 plus, oh, can I do 2 plus 2x and get 4x? Okay. Can't combine those.
You can't combine sine x and
It's multiplication. You can't do that.
No. The first, oh,
It's multiplication over addition. We've got sine divided by sine. What happens here? That sine cancels with that exponent. We've got sine plus cosine squared over sine. Oh, there's a fraction there. Fraction? Maybe it might be a good idea to combine those two. Common denominators. This is going to work your creativity, your algebra. Well, if we multiply by sine over sine, common denominator, that is 1. We're allowed to multiply by 1. That's going to get us Sine squared plus cosine squared over sine. And what we just saw, sine squared plus cosine squared, what do we get? That is 1 over sine, which is cosecant, just cosecant. So the whole point is, how can we combine these? How can we simplify down to as few parts as possible? It's going to work your algebra. Make certain that you can manipulate things appropriately. Last one.
What was it over, that was over sine?
Whole thing came to be over sine, therefore cosecant. Last one. Cosecant minus cosine times cotangent. Switch it. We've got 1 over sine minus what happens to the right. We see anything? Well, that we can combine. We've already got a common denominator. We've already got a common denominator. That gives us 1 minus cosine squared over sine. To me, that looks nice. What's 1 minus cosine squared?
1 minus.
Well, cosine squared plus sine squared is 1.
Oh, so it's sine squared.
It's sine squared. So we've got sine squared equals 1 minus cosine squared is sine. So this, by manipulating something that we already know, this is just sine squared over sine. Oh, easy peasy. We've got sine of x. And we're set.